Look at this view. Hey, there's an echo. Okay, that's better. Have you ever heard an echo before? Maybe in a gym or a tunnel? What do you think causes this? Let's review what we know about sound. We learned that sound travels as a wave, a longitudinal wave. It travels through different states of matter, such as solids, liquids, and gases. Sound travels in the same direction from where it began. That's why it's easier for you to hear me when I'm turned towards you rather than when I'm facing away. What happens when the movement of sound waves is interrupted, say, by a wall? What do you think happens? Let's find out. If you have your science log, go ahead and grab it. Otherwise, a piece of paper and a pen will do. Please write down this question. What happens when sound hits a wall? Then, write down your guess or hypothesis. Now, all you need is a wall. Stand about 2 steps back from the wall and count to 10 while slowly moving closer to the wall. By the time you reach the number 10, your nose should almost be touching the wall. Then, count to 10 again while moving slowly away from the wall and notice if anything changes with the sound of your voice. Give it a try and then record your observations in your science log. What did you notice? Did the sound stop as you got closer to the wall, or did it seem to get louder? What was happening is that the sound waves from your voice were reflecting against the wall and bouncing back, sort of like a basketball. When sound waves encounter a substance, there are 3 possible outcomes: reflection, diffusion, or absorption. Flat, hard surfaces like walls reflect sound because the sound waves can't penetrate into the hard surface, so they reflect. They bounce back. The next time you're in a gym, try clapping your hands and notice if you can hear the sound bounce back off the walls and floors. When a sound wave hits an irregular surface, the vibration breaks up and travels along many smaller pathways. This divides the energy of the wave, sending it in many different directions, which depletes its energy faster. This is called diffusion. Some surfaces absorb sound. This happens when the energy of the sound waves is converted into a little bit of heat energy, which dissipates, causing the sound to decay or fade out faster. Some materials that have this effect include cushions, blankets, and carpet. That's why a room with furnishings and carpet will generally be quieter than when it is empty. Here's an example of acoustic treatment foam that I use to record our videos. The foam absorbs some of the sound, which helps to keep my voice from sounding too echoey. Let's test the properties of sound reflection and absorption. For this experiment, you will need a container, a rubber band, a small towel, and your science log. For the first step, slide your rubber band over the open top of the container and pluck it with force. Notice how loud it is. Next, we're going to place the towel inside the container and pluck the rubber band again. Before we do, jot down this question in your science log. Will the sound be louder or softer after placing the towel in the container? Write down your guess or hypothesis. When you pluck the rubber band, make sure to use the same amount of force so that you can compare the two sounds. What were your results? If the sound was louder once you placed the towel inside the container, raise your hand. If the sound was softer after placing the towel in the container, raise your hand. Let's see what mine sounds like. And now, let's take a moment to compare those sounds. When the container was empty, the sound reflected against the hard surface. When the towel was placed inside, it absorbed some of the sound energy, which made it sound softer. Sound is all around us, and there are many ways to explore how sound is reflected and absorbed by different spaces and materials. Here's a DIY project you can try on your own. Choose 3 to 5 different places, such as a bedroom, a living room, a restroom, and outdoors, and clap your hands in each space. Notice whether you can hear the sound bouncing back. Also, observe how the sound changes depending on the size of the space and the materials in the environment. Thank you for joining me today and learning about the different ways sound travels when reflected, diffused, or absorbed. I'm Miss Liz with the Cincinnati Symphony Orchestra Sound Discoveries program. See you soon!